This is an interesting one. Back about 1990-ish, and I was still living in Paris, and I was just getting on the internet, but I was still doing most of my stuff on bulletin boards. And I was on the Intellect PBS network. We had a programming languages conference. And so I was on that with people from literally all around the world. And there was a guy who arrived in this programming languages conference, and he was a big fan of a thing called PBS Basic. The PBS stands for Professional Development System. It was a very complicated basic. And he was gung-ho on it. He says, anything you can do in any other programming language, I can do it better, faster, easier in PBS Basic. And all those programmers were like pointers, linked lists, data structures. And he's like, oh, don't tell me how to implement it. He says, just give me the problem and I'll show you how easily I can do it in PBS Basic. So we're like, okay. So I created a file, it was a big file back about 1990. It was a file with like 50,000 lines of messages I pulled semi at random from the PBS. And like PBS messages are in text mode, and then people have like ASCII, SIG files at the bottom of each message and all that kind of crap. And I said, okay, now here's these, and there are lists of CD-ROMs for sale and code fragments and all the kind of crazy stuff you have. And of course, bulletin board messages are not in any way structured. They're just random free-flowing text. So I said, here's this file, 55,000 lines of PBS messages. Write a program to go through here and find everything that looks like a complete name and international postal mailing address. It could be a British one, it could be a French one, German, Canadian, American, Swiss, Spanish, whatever. So it looks like a name and complete international postal mailing address. And he looked at the problem and he was, had no idea how to tackle it with PBS Basic. Because like most programming languages that do pattern recognition, most of them use regex, which of course was also born back in the late 60s when people were using teletype machines. ASR-33 was talking to little mini computers. And you wanted to use asterisks and question marks and all the kinds of little stuff that regex was based on. But regex, in days when you can create much more comprehensive issues than you can do with teletypes and mini computers, regex just isn't good for doing stuff like that. And so that's another part of the thing where Stonewall just blows regex away. As you'll start to see it, there's going into the detail of pattern matching and all the elaborate stuff it does. It would take a lot more than the time we have available for tonight. So basically, this is just sort of a quick introduction.
All right, welcome to the meetup. This is a Meet and Geek, in case you're wondering or you're lost. We're just a group of software people that are interested in meeting other people, learning something new. We're pretty much a free-form group, just mainly social. We have a presentation up front normally, and then we just get together and talk about cool stuff. I want to thank the Makerspace for allowing us to be here. This is DallasMakerSpace. It's an amazing, it's an amazing place.
If you haven't been here before,
it's right now. It's in a series of construction where everything's moving around. Because it went from 16,000 square feet to 36,000 square feet of everything you can think of to make something with. So laser cutters and a whole machine shop and a wood shop and everything that you could think to make something with.
Die sewing machine.
Yeah, I mean,
printers.
It's all kinds of stuff here. But yeah, I want to thank them for allowing us to have the meetup here. But we may go on a tour later on it. But
you need to do the tour if you haven't done it yet. It's very cool.
It is. But the presentation is obviously about SPITBOL.
Okay.
and I give it to you.
Thank you. Most everybody here has written code in one kind of a programming language or another, and they all have their advantages and disadvantages. And most of them are more alike than they are different, because they have, there's certain things that programming languages just sort of do, and then there's other programming languages that really don't work the same way at all. And so that's part of what's interesting about this one, and hopefully by the end of this presentation, you'll have been intrigued enough that you'll decide that you want to add this one to your toolbox. The platforms that this version of SPITBOL that I'm running on here run on is I'm using the SPITBOL version. Let me give you a bit of the history. I sort of covered this a little bit. SPITBOL originated as a sort of a secondary version of the Snowball programming language. Snowball originated at the Bell Labs in New Jersey back in the late 60s and early 70s. And it originated with a group of people that were working on symbolic mathematics. And as they were working on that, they decided that they wanted to write programs to do this symbolic mathematical stuff. And as they studied those programming languages that they could have to use to write their programs in, they discovered that those programming languages, none of them were really good for doing what they needed to do. So they said the first thing we need to do if we're going to do this is we need to write a programming language, create a programming language that's better for doing the type of stuff that we want to do. So they created Snowball, which became, when I first started at the University of Illinois in my third semester down there, which is when I learned assembler and data structures, I learned Snowball 3, which rapidly segued to Snowball 4. And at the time, Snowball 4 was running on a pre-6075 computer mainframe. It was $100,000 a month lease on this machine. It was the only 360 that was ever built that actually implemented all the instructions in hardware. There was no microcode, no firmware at all. It was a twin of the machine that IBM built to send astronauts to the moon on the Apollo project. It was a big, powerful machine. But it had a maximum memory capacity of 1 meg supported core memory in it at the time. And we had 2 meg of bulk core added from Memorex, which was semi-quasi supported. And Snowball, it turned out, it really wanted like 230K to run it. We had a total of about 470K available for user applications by the time OS 17 task was loaded. So it turns out that we could only run like 2 partitions of Snowball on OS 17 on a 360 mod 75, and they preferred to use something like PL1, which could run in 116K, which could run 4 jobs at a time. Anyway, so Snowball was the thing that our information structures class taught. And I didn't really learn it as learning Snowball. I learned information structures and was taught in Snowball, but I sort of lucked out, and that sort of being taught it. And I lucked out because we got into Snowball 4 about 2 or 3 years before the university sort of switched over to teaching students with PDP-11s and teletypes and stuff, which didn't have anywhere near the capacity to run a language as powerful as Snowball. They sort of got away from teaching this language, so I managed to slip through the two. So, some classic books. One of them is Algorithms in Snowball 4. This is a great book, and it talks about all kinds of neat stuff you can do in Snowball and how you attack different kinds of problems. Another classic book by Ralph Griswold, who's one of the inventors of Snowball, is String and List Processing. This is a neat book too. Occasionally you'll find these trading on eBay. And then I got away from Snowball when I came to work in San Antonio when I was at DataPoint Corporation, where we invented desktop personal computers and such. And sometime after that I managed to find this, which is Snowball 4 Plus. There were 3 or 4 versions of Snowball that came out for the PC. Cool, I get back into Snowball again. So Snowball 4 Plus came out. That's this one. And then Mark Emmer, who did this implementation based on the SIL implementation of Snowball, decided he really wanted to do an implementation of SPITBOL, and which is the one that I sort of finally centered on. But we'll get into a little bit more of that too. There are several versions of Snowball for PC users. Also a Minnesota Snowball, which is actually the guy who did that up in Minnesota, is back around and online again too. So anyway, SPITBOL is runs from the Windows command line, DOS, and C Snowball is another implementation of Snowball, where they took the SIL version of Snowball, converted to C by a translation, and then compiled it so that way, because it's now in C instead of SIL, it makes it easier to put it on other platforms. So Snowball, as it says, the name stands for String-Oriented Symbolic Language, and it was created at Bell Labs. And SPITBOL stood for Speedy Implementation of Snowball, and it's an enhanced version of Snowball 4 with a couple of notable enhancements that we'll get into. One of them being alternative expressions. Why SPITBOL? Everyone says, like, I've got other programming languages, why do I need another one? I don't really need it. SPITBOL is very powerful. It's fast as hell. One of the things that's really cool about it is that, unlike things like C, SPITBOL resists the typical bugs that most programming languages are subject to, and most typical malware attacks. They have no earthly idea how to deal with something like SPITBOL. It encourages you to think about problems in very different ways and more powerful ways than any other programming language you can use. And the programs are usually very short and quick to write, so you can throw together stuff really easy, oftentimes in SPITBOL, for the type of stuff it's good for. The language is also stable and mature because it's not subject to constant hassles and manipulations like other programming languages are. So they're not coming at you every 6 months or every 12 months saying, oh, you need to buy the new version, you need to buy the new implementation. It's going to be, we're going to make all these changes and completely uproot you from what you're used to. So what is it good for? SPITBOL is really good for back office type applications. Command line, utility, text mode. Although I say text mode, you can deal with binary data. So it's not like C where you have strings that are zeros from the and stuff like that. You can deal with raw data if you want. It's good for scripting. You can launch other programs from it. It's good for data scraping. One of the projects I did with SPITBOL a couple of years ago was I went out to the various state Democratic Party websites and collected the email addresses, names, and counties of Democratic state county chairs in like 14 states. I collected 1,100 Democratic county chairs so I could send them emails for a project I was working on. It's great for pattern matching. The only thing that's possibly better than Snowball for pattern matching is Icon, which started out as Snowball 5, and then they ended up making it a different language completely. Data manipulation, formatting, and one thing that's cool about SPITBOL is that you can actually compile and create exe files. So if you want to distribute just a simple exe file, people can run in their scripts or can run from their scripting tools. Makes it really, really easy to do that too. What's it not good for? It's not the sort of language you would use to write Windows GUI type apps. You wouldn't use it to write Android or iPhone apps. Although, as I point out here, you might be able to write a preprocessor that would generate Android or iPhone apps, possibly, I suppose. Although that's not what I would primarily be using it for. So to run a SPITBOL program, how do you actually, what's the process of running it? Normally you enter the program using your preferred editor. I just normally use a Notepad. End label terminates the program file. You write the program file to disk like you would any other text file that you run with your Notepad. You run the command, the compiler from the command line to compile and run the program. And you can either compile it to an exe file and run the exe file, or you can just run it directly from the compiler. And there's a whole variety of command line options that are available to control how it runs. How is it different from other programming languages? Okay, I covered some of this already. It does pattern matching without regex. It does not use regular expression like every other language that does pattern matching does. So it allows for much, much more sophisticated and far more powerful pattern matching and parsing than you can do with regular expression. One of the things that's different is that conditionals are based on success or failure. So things that in Snowball either they succeed and produce a value, which could be null, or they fail and produce no value. So like how in most programming languages, for example, if you want to pass back a result from a subroutine you've written or a function you've written, if maybe the input values were bad, it returns a minus number, or it returns something weird. but you have to test for them when you come back. Well, with SPITBOL, you just test for failure. And when you return failure, you don't return a value at all. And so the programs that you are using, that you're calling your various functions, either succeed or fail. Another thing that's interesting about SPITBOL is that it does not have the traditional keywords that every other programming language has. There's no if then else. There is no traditional do loops. There's no do while loops. There's no begin end blocks. Basically, it uses a completely different approach to passing control around, including within, especially within a pattern hash. And we'll get into that too. Another thing that's interesting about SPITBOL is that you don't declare variables. Okay? In most programming languages, you have to declare variables, and you do not in SPITBOL. And you can change the data type of the variable, although it knows what type of data you have stored in that variable, but you can change it any time you want by just assigning a value of a different type to it. And so variables can change types dynamically at any time, and can change back and forth. You can also, one of the things that's really cool about the language is that you can change the program at runtime. You can add more code to it. You can change the calling conventions of your subroutines and your functions. You can change variable names. You can create new labels. You can compile the program into an exe file that jumps to labels that haven't been defined yet. You can go and define them at runtime. You can likewise, you can compile new code at runtime that goes to labels which are in the compiled program that nothing used before. So it's just a lot of really strange and wonderful things that other programming languages don't have. So then the question is, what kind of variable types? I mentioned variables can change data types as often as you want. Obviously it has integers, it has reals, has strings, and the strings can contain any kind of characters you want, and there's no inherent size limit to a string. You can set an upper bound on string length, but you can take a string that you initially assign 5 or 10 characters to, and you can grow it to thousands and thousands and thousands of characters if you want. It's got arrays, which work much like the arrays of ordinary programming languages, but also it's got tables. Tables are like arrays, except that there's no inherent size limit to tables. And the subscript may be any type. So you can have a character string as the subscript of an array. You can have a real number as a subscript to an array. You can have, or to a subscript of a table. Subscript can be anything you want. You can actually use an array or a table as the subscript to a table. So that's sort of very unusual too. Pattern is a data type. Unlike, again, the things that use regex. Pattern is a data type, and you create patterns at runtime using pattern type built-in functions and various operators. You can have pattern expressions, and those can become quite complicated. Your patterns that you have in your pattern expressions can include user-called functions, user-written functions that can look at things that you've processed so far during the pattern processing and decide whether you want to proceed with that or not. So you can have user-written functions incorporated in your patterns. Code, which is one of the data types. So you can actually compile code and put it into a variable, or put it into the entry of a table, or put it into an array entry. And even for example, you could have the equivalent of a Klein bottle, where you can have a table where one entry of the table contains the entire table. Or likewise, the same thing with arrays. You can have an array where one element, A sub 1, contains the entire table of A, among other things. And in arrays or tables, you don't have to have the same type of data. Again, each element can have a different type of data any way you want. You can change those dynamically too. The other type that is a variable data type is a thing called a user-defined data type. User-defined data types are basically structures. And you create these again using there's a function call at runtime that you can define based upon a character string what you want the data element to be called and what you want, what fields it's going to contain. And when you create it, it creates a built-in function, it creates a new function you define with the name of the data item that will create a version of that data item, a copy of it. And when you run that, it also creates the access functions that will allow you to access the individual fields of that structure. And since you can put, for example, code into a structure, into a user-defined data type, that also allows you to use basically object-oriented programming, because you can put in, attached to each copy of this user-defined data type, you can have custom code that is used to access the different fields of that structure. You can change it on a data item by data item basis if you want. Statement format. Snowball statements are actually rather cool. There's basically three types of lines. Comments. Comments start in column 1, or you can have a completely blank line, which is also a comment line.
You computed that.
You can have continuation lines. Continuation lines are sort of a little bit like fortran, although you start with a plus sign in column 1 to indicate that this line is a continuation of the line that went before it. And then you have executable statements. And executable statements consist of 5 parts, and all 5 parts are optional. So you can have many different combinations, and we'll show you some examples of how these work when you actually bring it up and show you some. Again, the label starts in column 1 if there's a label on that statement, and that's used if you're doing a go to transfer control to that statement. Then there's a subject, then a pattern, an object, and a go-to. So the way it looks, for example, on a typical line, you have your label, you have a subject, you have a pattern, object, and go-to. Label and subject are separated by white space. Subject separated from the pattern by white space. There can be white space in the middle of a pattern, in the middle of a subject or pattern that day too, but there's white space at like lowest level. Then there's an equal sign, which separates the subject and pattern from the object. And there's white space, a colon, and possibly parenthesized lists for your go-to. So the way this works, and again, this is an example of what a typical snowball statement looks like. The label usually is just a name. It can be an expression, but usually it's just a simple name. So the first thing that happens is that the subject is evaluated if necessary. It might just be a simple variable, but often you'll have a subject, might be a function call or something. Then the pattern is evaluated. And again, patterns are created at runtime usually, but you can store pattern in a variable too, so you don't necessarily have to do it every time that pattern is executed. Then, assuming that everything has worked, it then, after it's evaluated the subject, which might be a character string, for example, then it has processed and created the pattern. The next thing it does is to process that pattern against the subject in what's called a pattern match. And this can be very, very sophisticated in terms of how that can get done. There's many different ways of doing pattern matching. Is a big subject all by itself. If the pattern is found in the subject, or if there is no pattern, then it evaluates the object, if there is one, and then it replaces the portion of the subject matched by the pattern with the object. Okay, if there is no pattern, then basically it matches the entire subject, and it just assigns the object to the subject. And then, following that, then there's the go-to. And again, these are based on either success or failure or unconditional, and there may not be a go-to at all, in which case it just follows through to the next stage in sequence. User-defined functions are created also at runtime using the define built-in function. And just like when I said there's a thing for creating these user-defined data types, you have a define creates user-defined functions. It creates the function name, the label of the start, where the start statement, the names of the parameters that are being passed to the function, and it also can include local variables which are automatically stacked when you do the function call, and will get automatically destacked and restored their original value when that function returns. If you don't put it down as a local variable, then your function will have access to the variables of the same name that existed outside the function call. So a function returns a value by assigning it to the variable matching the name of the function and succeeding. And succeeds by doing a return go-to. It returns failure by just going to f-return instead. These are pseudo labels, return and f-return. Operators. There's two types of operators, basically. There's binary and unary operators. Binary operators basically are separated by white space from what goes before them and what comes after them. You got your traditional arithmetic operators, plus, minus, multiply, and divide. Explicit pattern match. If you want to use pattern match within an expression, then you can do an explicit pattern match because you don't have the white space like you can do the subject to the pattern. You can have alternatives, which allows you to say this or that. You can do that in a pattern. Conditional, which is a conditional assignment. In a pattern match, you can have, as you're going through the pattern match, you can have things that match parts of the subject. And conditional just says, remember the stuff that I just matched, and if I found it, and if the pattern match succeeds, go ahead and save that part of what I matched to the subject and save it into this variable, the variable that follows. You can store it in a table entry, whatever you want. Immediate assignment is the same sort of way, except that instead of assigning it only after the complete pattern match succeeds, immediate assignment allows you to save the part matching previous portion immediately to a variable. So you can, for example, you can record that into a variable, and then later you can call a user-defined function and pass the preliminary results of your pattern match to a piece of code that you've written, and decide whether you want to proceed with the pattern match or you want to try something different. White space is a concatenation operator, both in the statement and in the patterns. Then there's unary operators, which is like a leading minus sign in a number. Deals with the value that's immediately after that. So there's minus sign, which is negation. That negates the status of, that's not minus sign, but that's actually it. Well, yeah, negation. Okay, negation for numbers. Then there's a null, the null sign, which interchanges success or failure. It swaps to make something that would otherwise succeed fail, and something that would otherwise fail succeed. Question mark says, ignore the value of the thing after this. Just only use the fact whether it succeeds or fails. And then there's asterisk, which says defer the evaluation. So what this is doing is it allows you to put stuff in that are going to be evaluated at runtime and at the point where the pattern match is in process, and not when the pattern is being created. Okay? So this allows you to call user-defined functions during the pattern match as many times as necessary, and not just during the creation of the pattern. Okay? One of the things that's really cool is alternative evaluation expressions. This is something that is sort of the replacement for complicated nested if-then else. And what this is it's basically a parenthesized list of expressions. And these can be very complicated expressions. They can be pattern matches, they can be all kinds of stuff. And it essentially evaluates the expressions one at a time until one succeeds. And when the first one succeeds, it then takes that, doesn't evaluate the rest of them in the parenthesized list, and it returns the value of that expression as the value of the complete expression that it's part of. And I'll show you some examples of how this is used. This is one of those things that until you actually see how it works, it's hard to appreciate how powerful this is. But it's something that you use a lot. Input output. Now this is the last slide of the presentation, basically, of this particular presentation. Variables can be associated with files. That's how you do your input output. You use a function to associate a variable, the main variable, with a file. And so by default, the variable named input is assigned to standard, is associated with standard input. Output is a variable that's assigned to standard output. Terminal is a variable that's assigned by default to the keyboard and display. So every time your program references the variable terminal, it waits for the operator, the user, to key something in, and then it returns you whatever the user keyed in. Output, likewise, you assign something to output, and that will send it to your standard output file. Likewise, every time you reference input, you get something from the standard input file. If you reach the end of file, input fails. So that's how you know that you've reached the end of that. So whenever you access a variable, it returns the next record of that associated input file. Depending on how it's opened, that might be a block of binary data. It could be normally it's a line of text. You can give it blocks, so you can get a big block of text, but only return this portion. And likewise, when you assign the value to a variable that's associated, that is written to the associated output file. And that's the end of that part of the presentation. I'm going to show you an example here. For example, this is an example of a neat-little spitball program I wrote. And this is done so instead of having to show you how stuff works, instead of having to go in and enter it into Notepad and then go and you store it from Notepad to disk and then go get it and bring up the compiler to run it. I wrote a program it basically interprets snowball statements one at a time, or spitball statements one at a time. So you can actually type them in one at a time and see the results right away. And you don't have to go back and forth to Notepad, back and forth to the compiler, et cetera, et cetera, et cetera. So as an example of a simple spitball statement, for example, might be like x equals 1. That part looks pretty much like ordinary programming languages. You know immediately what that does. It assigns an integer 1 to x.
Sorry, 1 second. Could you move your terminal just a little bit to the side? It's not outputting quite
Oh.
to the screen.
Sure.
Maybe shift a little bit.
Better? Yeah. Great. Thank you. Okay. So, and likewise, if you want to put a string, you can say, like, for example, s equals some string. Has that created the value there? I could assign some string to x now. The fact that it was an integer before, I can change it whenever I want. And the value type of variables can change dynamically. So we'll just create a variable called v. Actually, I'm going to create a statement with a label. This is going to be a simple one to show sort of some input and output, or some output capabilities. We're going to call this show v. Will be a label. And we're going to say terminal equals v. And then display the value of v. And then we're simply going to display type and the data type of v. Okay? Try that with my quotes right. Okay. So initially, v is a null string and type string. If I take v and assign the value of s to it, for example, and then say go to show v. All right, that displays the new value of the variable v, and now it's a string type. So one of the things I showed you here is that the statements I'm interpreting in my little interpreter remember labels from previous statements. And obviously the stuff I'm doing was not defined when the program was compiled. Let's take a simple pattern match. Well, let's take a name